Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about definition and terminology of water technology. So what is define hardness of water? Define hardness of water. So hardness of water is that characteristic which prevents the lathering of soap. So this is due to the presence of salts of calcium, magnesium and other heavy metal dissolved in it. So hardness of water, when we treat it with soap, it doesn't produce lather. Why it doesn't produce lather? Because it's present calcium, magnesium ions of bicarbonates, chlorides, sulfates, etc. present in water. So that's why when we treat it with soap, it doesn't produce lather. So that is called hardness of water. So what are the sources of water? So the main source of water are rainwater, river water and groundwater and seawater. So the main sources of water are rainwater, river water, groundwater and seawater. So what is hard water? So water which does not produce lather with soap solution on readily. Does not produce soap lather with soap solution readily but forms white curd is called hard water. So simply we say when we treat it with soap it doesn't produce lather, but in soft water absence of all the hardness causing ions, that's why it produce lather. So what is hard water? Hard water means when we treat it with soap it doesn't produce lather but it produce white curd is called hard water. And what is soft water? So when we treat it with soap, it produces lather. Why it produce lather? Because absence of all the calcium, magnesium ions of bicarbonates, chlorides, sulfates, etc. present in water. So that is called soft water. So water which lathers easily on shaking with soap solution is called soft water because of its absence of all the hardness causing ions which are present in water. So this water is called as soft water. What are the temporary hardness causing salts? So in water already we know that which type of hardness causing ions present? Calcium, magnesium ions of bicarbonates, chlorides, sulfates, etc. present in water. So that's why when we treat it with soap it doesn't produce lather. But in this hardness also classified into two types: temporary hardness and permanent hardness. So what are the temporary hardness causing salts present in water? So calcium, magnesium ions of bicarbonates present in water, that water is considered as temporary hardness of water. So the temporary hardness causing salts are carbonates and bicarbonates of calcium and magnesium. And next question is, what are the permanent hardness causing salts? So the permanent hardness causing salts are sulfates, nitrates, chlorides of calcium, magnesium. So generally in water it is present total hardness means the combination of temporary and permanent hardness causing salts. So temporary hardness causing salts are calcium, magnesium, bicarbonates. But permanent hardness causing salts are calcium, magnesium, chlorides, sulfates, etc. present in water. So this water considered as permanent hardness of water. So what are the total hardness causing salts present in water? So just now we discussed already. What is that? The combination of temporary and permanent hardness causing salts present in water. So that water is considered as total hardness of water. So there are 8 different hardness causing salts are there. They are calcium bicarbonate, magnesium bicarbonate. These two are related to temporary hardness causing salts. Temporary hardness causing salts. And calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, calcium nitrate and magnesium nitrate. So this also present, if it is present in water, so that water is considered as total hardness of water. Total hardness of water. So what is degree of hardness? So degree of hardness, it is defined as the amount of hardness causing salt by molecular weight of hardness causing salt into 100. So simply we say here weight of hardness causing salt by molecular weight of hardness causing salt into 100. This is the formula used for this calculation of hardness causing ions in the terms of CaCO3 terms. Or degree of hardness means degree of hardness is defined as the amount of the hardness causing salt by molecular weight of hardness causing salt into 100. This is called degree of hardness. So what are the various units of hardness? So general units of hardness is parts per million, milligram per liter, Clerk's degree and French degree. So there are 4 types of units of hardness are there: parts per million, milligram per liter, degree of Clerk and degree of French. So define parts per million. What is ppm? Parts per million. So the number of parts by weight of calcium carbonate equivalent of hardness causing salt present in 1 million parts of water, or otherwise 1 ppm equals. So number of parts of calcium carbonate equivalent hardness in 10 to the power 6 parts of water is called ppm. So what is meaning of parts per million? The number of parts by weight of calcium carbonate equivalent of hardness causing salt present in 1 million part of water, 10 to the power 6 parts of water is called parts per million. And what is the meaning of milligram per liter? Define milligram per liter. So the amount of calcium carbonate equivalent hardness salt in milligram per present in 1 liter of water, or the number of milligrams of hardness causing salt converted into calcium carbonate equivalent present in 1 liter of water is called milligram per liter. So you are taking density of water as unity. 1 kilogram of water at 4 degrees centigrade is equal 1 liter. So 1 kilogram of water is equal to 10 to the power 6. So it becomes number of parts of hardness causing salt in 1 million parts of water, which is equal to parts per million. So that means 1 ppm equals 1 milligram per liter. Mathematically, both are equal. Next, define degree of Clerk. So the number of grains of calcium carbonate equivalent of hardness causing salt present in 1 gallon units of water, gallon of water, or the number of parts by weight of calcium carbonate equivalent of hardness causing salt present in 70,000 parts of water. So simply says the number of parts of hardness causing salts converted into calcium carbonate equivalent in 70,000 parts of water is considered as degree of Clerk. Next, what is the meaning of degree? Define degree of French. Degree of French. So the number of parts by weight of calcium carbonate equivalent of hardness causing salt present in 10 to the power 5 parts of water. So what is the meaning of degree of French? The number of parts of calcium carbonate equivalent weight in 10 to the power 5 parts of water is called degree of French. So what is complexometric method? So complexometric method mainly used for estimation of hardness present in water. So this here complexometric titration is a form of volumetric analysis wherein the colored complex is used to indicate the endpoint of titration. So simply we say complexometric method is also called as EDTA method. So here EDTA forms complex with hardness causing ions. So that's why here this method is called complexometric method. So here we are using indicator is EBT, aerochrome black tea. It is used for identification of end point of water. So what are the types of hardness? So hardness means it's present calcium, magnesium ions of bicarbonates, chloride, sulfate, nitrates present in water. So when we treat it with soap, it doesn't produce lather. So that water is called hard water or hardness. So how many types of hardness are there? So there are two types of hardness are there, temporary hardness and permanent hardness of water. So there are two types of hardness, temporary hardness and permanent hardness of water. So what is the principle involved in this EDTA method? So what is the principle of EDTA method? So here it binds the metal ions in water to give stable chelate complex. So hence it is called complexometric titration method. So here what is the main principle involved in this? First, hard water means it's present calcium and magnesium ions present in this hard water. So in this hard water is present calcium and magnesium ions present in that water. So when we are adding indicator, EBT indicator in the presence of buffer. So here it forms calcium and magnesium EBT complex is formed. But it is highly unstable complex and the color of the complex is wine red. But next, this wine red complex is treated with EDTA from the burette. So in this case, it forms calcium and magnesium EDTA. Stable complex is formed and the color changes to wine red to blue, that is indicate free indicator EBT. So wine red to blue color changes. This is the principle involved in this EDTA method. So first, these hardness causing ions which are present in water. When we are adding indicator, the color of the solution is wine red color. So in this case, what is the reaction takes place? Calcium, magnesium, EBT complex, weak complex is formed. So this complex when titrated with EDTA from the burette, so here it forms calcium, magnesium, EDTA stable complex. That means EDTA replaces EBT. So calcium, magnesium, EDTA complex is formed. And the color of the solution is wine red to blue. That blue color indicates free indicator EBT. Next question is, write the pH used in EDTA titration. So we use pH. What is the range of buffer? What is the maintaining pH range in this complexometric method? pH 9 to 10. So we use pH 9 to 10 is used in complexometric titration of EDTA with metal ions present in hard water. Why we are preferring only this pH range only 8 to 10? Because at this range only EDTA forms complex with hardness causing ions. So that's why we are maintaining pH ranges 8 to 10. Next, write the full form of EDTA and EBT. So EDTA, ethylene diamine tetraestic acid. Ethylene diamine tetraestic acid. And EBT, aerochrome black tea. So in this method, EDTA acts as complexing agent and EBT acts as indicator. So what are the impurities present in water? Generally, which type of impurities present in water? Suspended matter, dissolved substances, colloidal impurities, sand, organic impurities, etc. present in water. So what is the expression of hardness? So already we know that in previous classes already we discussed so many numericals also based on that hardness causing ions conversion in calcium carbonate equivalent. So what is the expression of hardness? So hardness of water is expressed in terms of CaCO3 equivalent, calcium carbonate equivalent. Why we are converting only calcium carbonate equivalent? Because in water so many different types of hardness causing ions present. So all these hardness causing ions, how much amount present in that water, so it can be calculated when we converting calcium carbonate equivalent. That means it makes calculation is very easy. Why we preferred, we have to preferred only calcium carbonate. So many hardness causing salts are present in water, but we are preferring only calcium carbonate. Why? Because calcium carbonate is highly insoluble in water and its molecular weight is 100 and equivalent weight is 50. So it makes calculation is very easy. So what are the disadvantages of ion exchange process? So the ion exchange resins are expensive. Cost of the purification is very high. Generally, what purpose we are using this ion exchange method? Hard water converted to soft water by external treatment method. But what is the disadvantage? Here, that cost of resins are very expensive and purification is also very high, expensive. So what is softening of water? So here, generally soft water means absence of all the hardness causing ions. So when we treat it with soap, it doesn't produce lather. When we treat it with soap, it produces lather is called soft water. So here softening of water means the process whereby the removal or reduce the hardness of water. The process whereby remove or reduce the hardness of water, irrespective of whether it is temporary or permanent, is termed as softening of water. So next question is, what is potable water? So drinking water, also known as potable water. Drinking water, also known as potable water. So the water which is used for human consumption is called potable water. So simply we say domestic usage water is called potable water. So generally this water is collected by municipalities for our domestic usage purpose. But this water contains so many impurities. So before they are supplied, they have to purify this water. So it is used for domestic and drinking purpose. So that water is considered as potable water. So what is screening? So just I discussed already, the main source of water is rivers, lakes, ponds, etc. But this water containing so many impurities. So before the municipality supply this water for our domestic usage purpose, they have to purify it. So in this first step is screening. So this water is passed through the screeners. So the screeners is having large number of holes. So when we pass this through the screeners, so it containing generally screeners having large number of holes to remove floating impurities. So what is that floating impurities? Like wood pieces, leaves, papers, etc. So this water, when we pass it through the screeners, in this case remove floating materials which are present in water like wood pieces, leaves, papers, etc. And what is filtration? So filtration helps to remove colloidal and suspended impurities which are not removed by sedimentation. So all that such type of impurities removed by this filtration method. Mainly in this filtration process, it can be remove suspended impurities and colloidal impurities which are not settled down at sedimentation process. All those impurities removed by filtration process. What is sedimentation? So water is allowed to stand undisturbed for 2 to 5 hours. That means after completing the screening process, water is passed to the large stable tank. So when we pass this water in this, it is all the heavy particles settle down at bottom of this tank. So water is passed through this stand or tank, stable tank, do not disturb for 2 to 5 hours. So in this case, all the large particles settle down at the bottom of the tank due to gravity. So this process is called sedimentation. Next, define chlorination. So chlorination means the process of applying calculated amount of chlorine to water in order to kill the pathogenic bacteria called chlorination. So the process of applying calculated amount of chlorine to water. So what purpose we are adding chlorine to water? To remove the bacteria, kill the bacteria which are present in water. So the chlorination means calculated amount of chlorine to water. What purpose we are adding? To kill the pathogenic bacteria is called chlorination. So what is breakpoint chlorination? So the amount of chlorine required to kill bacteria and to remove organic matter is called breakpoint chlorination. So the amount of chlorine required to kill the bacteria and remove the organic matter is called breakpoint chlorination. It is clearly explained by taking graph. So in that graph, x-axis we are taking applied chlorine, y-axis residual chlorine. It is clearly explained in previous classes already. So here just a definition of breakpoint chlorination is at which point chlorine completely removes all the bacteria which are present in water and organic matter. So all the remove when we are adding chlorine. So at which point chlorine removes all the bacteria or any organic impurities present in water. So that point is considered as breakpoint chlorination. So what is sterilization? So destruction of harmful pathogenic bacteria. Destruction or removal or destruction of harmful pathogenic bacteria from drinking water. From drinking water is called sterilization of water. It is also called as disinfection of water. So destruction of pathogenic bacteria, harmful bacteria completely removed from water is called sterilization or disinfection. So what is ozonization? So in this method, ozone is passed into the water which acts as a disinfectant. So ozone is unstable isotope of oxygen. So it produces nascent oxygen which is a powerful disinfectant. So here ozonization means ozone is passed through this water. So but ozone is highly unstable, so it is decomposed into oxygen and nascent oxygen. So this nascent oxygen is most powerful disinfectant than ozone. So it reacts with bacteria and kills the bacteria. So this process is called ozonization. Next, what are chloramines? So chlorine is mixed with ammonia in the ratio 2:1. Chlorine is mixed with ammonia in the ratio of 2:1 by volume to form stable chloramine. To form stable chloramine, chlorine and ammonia. So both are taking in 2:1 ratio. So in this case it produces chloramine. Name any two coagulants. So coagulants means like alum, sodium aluminate and salts of iron, etc. So what purpose we are adding coagulants in the water? Because all those which are not settled down at sedimentation process, that are clay, sand, that type of impurities removed by adding this coagulants like alum or sodium aluminate. What is external treatment? So the treatment given to water for the removal of hardness. Removal of hardness causing salts. Removal of hardness causing salts before it is taken to the boiler. Mainly what purpose we are using this sectional treatment? Removal of hardness causing ions. Before that water we have taken boilers. Generally boilers used for to produce steam generation purpose, power generation purpose we are using. So before filling this water in that boilers, we have to purify. That means we can remove hardness causing ions which are present in that water. So that is called external treatment of water. That purpose we are adding some ingredients or chemicals. And what are the cationic exchange resins? So cation exchange resins are capable of exchanging their H plus ions. Cation exchange resin is RH2 or RH plus. So this cation exchange resin capable of exchanging their H plus ions into the water and absorbs all the cations which are present in water. It is called cation exchange resin, mainly used in this ion exchange process. Removal of cations which are present in water, and it gives their H plus ions into the water. Best example, styrene divinyl benzene. Styrene divinyl benzene. What is anion exchange resin? So anion exchange resins are capable of exchanging their OH minus ions with anion of the dissolved salts. So cap ROH2 symbol or ROH. So this anion exchange resin is capable of exchanging their OH minus ions into the water and absorbs all the anions like chlorides, sulfates, nitrates, etc. which are present in water. So it absorbs all the anions present in water and it gives their OH minus ions into the water. Best example of anion exchange resin is phenol formaldehyde resin. Phenyl formaldehyde resin. And next one is, what is the internal treatment of water? So internal treatment of water, the softening of water carried out inside the boilers is called internal treatment of water. So in this process, the hardness causing dissolved salts were prohibited. So internal treatment of hot water means we can remove hardness causing ions or sludge scales by adding, internally we are adding some chemicals in water. Such type of internal treatment methods are Calgon conditioning, pass pit conditioning, colloidal conditioning. So we are adding chemicals in boiler feed water, we can remove sludge and scales or precipitates or hardness causing ions which are present in water. So this treatment is called internal treatment of water. And next, define deionized water. Deionized, to completely remove all the hardness causing ions and minerals which are present in water. That means that in that water is present only H plus and OH minus. So here water coming out from the exchanges is free from cations as well as anions. So ion free water is known as deionized water. It is also called as demineralized water. So in that water is present H plus and OH minus ions. Remaining all are absorbed by cation exchange resin and anion exchange resin. So in this process we can remove all the cations and hardness causing ions or minerals, anions, etc. all are removed. Only it's present H plus and OH minus ions. So this water is called demineralized water. What is the treatment of water? So the process of removal of hardness causing salts from water. Removal of hardness causing ions. What is that hardness causing ions? Calcium, magnesium ions of bicarbonates, chlorides, sulfates, nitrates, etc. present in water. So removal of hardness causing ions present in water is called treatment of water. So what is coagulant? So coagulants are substance which cause particles in a liquid to curdle and clot together. It forms colloidal precipitates, smooth precipitates. So it removes the impurities. That purpose we are adding coagulants like sand, silica, etc. type of impurities cannot settle down in that sedimentation process. So such type of impurities are removed by adding coagulants like alum or aluminum sulfate, etc. And next question is, what are the chemicals used for regeneration of ion exchange process? So the chemicals used for the regeneration of ion exchange process are HCl and NaOH. So if in case cation exchange resin, for example, it can be exhausted by using totally. So in this case, it can be regenerated by using dilute HCl or H2SO4. The same way, anion exchange resin is exhausted. So in this case, it can be regenerated by using dilute NaOH. So these two are mainly used in this ion exchange method, soft hard water converted to soft water. So in this session, we'll learn about definition and terminology of water and its treatment. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.